All right, so unit 4 has to do a lot with reactions in solution. So let's talk about solutions are first. So solutions are a homogeneous mixture. So homo means same. And so homogeneous mixtures are things that are mixtures, so a combination of different compounds, but it looks the same throughout. So a good example would be like salt water, right? So salt water contains salt and water, but it kind of looks the same throughout. That's what a homogeneous mixture is. Okay. So when you have a homogeneous mixture, it's made out of two things, or sorry, a solution is made out of two things. So you can think of it like this. A solution is made out of something called a solvent, and it could also be made out of a solute or multiple solutes, depending on what the solution is. Okay. Now, the difference is pretty easy. The solvent is whatever you have more of, and the solute is whatever you have less of. Okay, that's the only real difference. So this whole ugly paragraph could be summarized like this. Okay, a solution made out of solvent and multiple solutes if possible. Solvent is something that you have more of, and solute is something you have less of. Okay, so yeah, for the most part in this unit, the solvent that we'll be talking about is water. For the most part, it will always be water when it comes to our chem classes. Okay. And we'll be talking about two different types of solute. The first is electrolytes, and the second is non-electrolytes. So you guys have probably heard that term before, right? With like Gatorade or body armor, stuff like that. Electrolytes are super simple. Electrolytes are compounds that dissolve in water, and they contain ions, and thus they conduct electricity. Okay. So I have this graphic here. I don't know if you guys can see it, but hopefully you have it on your Chromebooks. But electrolytes, when you dissolve them in water, they can allow electricity to flow through that solution. Okay. And then non-electrolytes, they don't form ions in solution, so they stay together. Okay. Yeah.
So if you drink like a bunch of Gatorade and then got struck by lightning, would it have more of an effect after I drank the Gatorade?
No, you have to complete the circuit. So
if you drink a lot of Gatorade,
how about this, guys? Next time it rains, drink a lot of Gatorade and go outside, okay? And then hold a metal pole up and let's see what happens, okay? Let's do that. Yeah.
It's a fancy word. It's like something that electricity. Not the word?
What fancy word are you looking for?
I don't know, the one that means like electricity can pass through it.
Probably conductor. Yeah. So if we can visualize real quick, the difference between an electrolyte and non-electrolyte. Okay, so let's look at electrolytes. So an example of an electrolyte is something like salt, okay, NaCl. So if you put salt inside of water, it's going to break apart into ions. That's what an electrolyte is. So it breaks apart when you put it in solution. Okay. An example of a non-electrolyte would be something like sugar, C12H22O11. I might be wrong about that formula. But if you put sugar inside of water, it stays together. The entire molecule stays together. Okay, so that's the difference between an electrolyte and non-electrolyte. Electrolytes, they will break apart into their ions. Non-electrolytes, they do not break apart into their ions. Okay, so that's what the difference is. Everybody good with those definitions? Chilling so far?
Yeah.
Okay. Okay, let's move on. Okay, now we're gonna focus a lot on electrolytes today. And there are two types of electrolytes. There are strong electrolytes and weak electrolytes. Okay, so let's talk about strong first because strong is the easiest ones to work with. Strong electrolytes are compounds, when you put them in water, they have almost a 100% dissociation. Okay, so basically almost every single molecule will break apart into their ions. Okay, so for example, HCl is a strong electrolyte. You put HCl in water, it will almost completely, every single molecule will break up into H plus and Cl minus. Okay, and so if you guys notice right here, it's signified with an arrow sign that goes only one way, okay, because almost every single one of the molecules break apart. Okay, make sense? Okay. The other is called a weak electrolyte, and weak electrolytes, they have poor dissociation, which means that not every single one of the molecules breaks up into the ion. So for example, we have acetic acid, which is the active ingredient vinegar. Acetic acid is a weak electrolyte because not every single molecule breaks up into the ion. So we signify that with the arrow sign that goes backwards and forwards, because it signifies that not every single one of them breaks apart. Okay, so that's the difference between strong and weak. Strong, they break apart completely. Weak, only some of them break apart. Yeah.
Should it be the other way around?
Yeah, that's what I thought too, but electrolyte means break apart, so strong, so good at breaking apart, I guess. I don't know. I don't make up these definitions. Some of these don't make any sense at all. All right, make sense? Easy peasy? Okay. So let's talk about how these electrolytes break apart in water. Okay, so we have a picture here of sodium chloride, okay, which is salt, and then we got purple dots signifying sodium and green dots signifying chlorine. Okay, so we have this block of salt, let's say, and then let's say that we put it inside of water. Okay. Okay, now we know that sodium forms a positive ion, right? And chlorine forms a negative ion. Okay, now when we take a look at a water molecules, they're called polar molecules because one side of the molecule will tend to be slightly positive and one side will be slightly negative. And so what happens is when you put salts or any electrolyte inside of water, the water molecule will attack that piece of electrolyte and it'll separate them bit by bit. They'll circle them like this. The negative side of water will surround the positive ion and break it apart from the rest of its family. And then the negative side of water, or the positive side of water, will surround the negative one and break it apart from its family. Okay, so you can kind of think of it as like an attack. The water molecules attack the electrolyte and separate them based on their ionic charges. Okay. And the key thing is because water is polar. One side, I don't know if you guys can see it very well. I'll kind of draw it bigger, but water looks like this. Okay, H2O. The side with the oxygen is slightly negative, so we signify it like that. But then the side with the hydrogens are slightly positive. We're going to talk about why that is in future units. But if you have something like water, where one side is slightly negative, one side is slightly positive, it'll be attracted, right, to the negative chlorine on this side, and it'll be attracted to the positive sodium on this side. Okay, so that's kind of the mechanism of how these electrolytes break apart in water. Okay, make sense? Everybody says it makes sense. And then when I grade the test, I have to do a lot of marking on it. My hands kind of hurt, guys.
I can help grade your test.
I could give you full credit, but then again, I can't fail you then.
Yeah, if you want me to like grade my own tests.
No, I'm good. Okay, so let's go over 4.1. We're gonna skip that part. We've already talked about this, but 4.1, and we're gonna draw some pictures representing some aqueous solutions. Okay, so let's start. I'll do the first one with you guys, and then I'll have you guys do the second one on your own. Okay, so we'll do part A. And for part A, we are looking at NiSO4, nickel sulfate. Okay, so we're going to put our nickel sulfate inside of a container. This is my water. Okay, so what we want to do is we want to figure out how many of each ion is formed when we put our ionic compound in water. Okay, so somebody can raise their hand. What is one of the ions that will form when you put nickel sulfate in water? Yeah, nickel will be one of them. So Ni. And then what's the other one? Sulfate, so SO4. Okay. So if you guys remember from the ionic compounds, you need to memorize what is the charge on sulfate. 2 minus, good. And there's only one nickel balancing it out. So what's the charge on nickel? 2 plus, good. So that's what will happen when you put nickel sulfate inside of water. Okay. Now we want to look at the second part too. How many anions would you show if each diagram contains 6 cations? So let's say that we had 6 nickels in there. How many sulfates will we end up with?
6.
6, yeah, 1-to-1 ratio. Okay. Make sense?
Yeah.
Okay. You guys think you can try the rest of them? All right, so I'll give you guys about 3 minutes. See if you guys can do B, C, and D on that. I'll make sure that you guys write the charges for the cations and anions. You can split it with the people next to you, but we'll go over them in 3 minutes, all right? Alrighty, guys, so let's take a look at B. So if we take a look at B, we have calcium nitrate. I'm just gonna write, I'm not gonna draw this picture, I'll just write the ions, okay? You should have said that it dissociates into Ca2 plus, and it should dissolve into 2 nitrates. Everybody got that? So 1 calcium and 2 nitrates, yes. Yeah, great question. So if you take a look at it, the formula has nitrate in parentheses and a 2, right? Now, those are individual nitrate ions, so they're going to want to dissociate separately. You don't break the polyatomic. Since it's a polyatomic ion, that ion likes to stay together. Okay, good question.
But it's like 6 cations.
Yeah, so we're gonna get to that part. I'm not there yet. Yeah. Thank you, though. I know, patience. All right. So if we had 6 cations, how many nitrates would we end up with? 12. Yeah, 1-to-2 ratio. Okay. All right. Let's move on to part C. For part C, you should end up with 3 sodium ions and 1 phosphate ion. PO4 3 minus. Okay. Any questions on that one? Yeah, I'm expecting 100% again, just like this past test, right?
Yes.
Oh,
Yeah, except for science question.
Except for the last FRQ, that's half the test, right?
No,
All right.
Like most of the FRQ, I just like forgot what.
Okay, so if we had 6 sodiums, how many phosphates will we have? Yeah, 2.
Oh.
Yeah, divide by okay. All right, and then last one, part D, you should end up with 2 aluminum ions, which is 3 plus, and 3 sulfate ions, which is 2 minus. So if we had 6 aluminums, how many sulfates will we end up with? 9. Yeah, 2-to-3 ratio, because if you look at it, if you divide by 2, it'll be 1 and 1.5, but yes, 2-to-3, that's the ratio. Hold up, you're being recorded. What? You're gonna give me $1 million?
$1 million.
And got that on record. Yeah. What's up? Is it this last one right here?
Yeah.
Yeah, so it's a 2-to-3 ratio. So easy way to think about it is 2-to-3, right? 2 ALs per every sulfate. And so if you have 6 aluminums, right? Then you just solve for X and then it'd be 9. So if, yeah, for these ratios, just write a fraction. I think that's the easiest way. That's what I personally do. Good question. Any other questions? All right. All right, let's move on to the next one. So, when we are reacting to different electrolytes. So for example, we have PbNO32 and we have Ki. Okay, these are both electrolytes, right? They're 2 ionic compounds. When you put them both inside of a solution, there's a tendency for these ionic compounds to create something called a precipitate. So if you take a look at this reaction right here, you'll see that this compound right here is aqueous, which means it dissolves in water. So you wouldn't really notice it in the solution. This one is also aqueous. So you have 2 chemicals that dissolve in water, right? But when you mix them in water, you're in the way, dude. Did you need it? Sorry.
Yeah, I did.
I was just messing with you. Bye. All right, so if you mix these two compounds that dissolve in water, okay, you're gonna end up with a solid. So you have two things that dissolve in water, but then if you mix them together, they react together to create a solid. And the solid that is formed is called a precipitate. Okay. So that's what we're going to be talking about. How to figure out if a precipitate is formed when you mix two aqueous solutions together. Yeah. Yeah, it's going to be two. And I'll talk about why. All right, so let's talk about why this happens on a chemical level, okay? So if you take a look at, let's take a look at the first compound right here. What's the cation that comes out of it? Yeah, lead, and what's the charge? +2, yeah. And then the anion is obviously NO3 minus. I know it's going to be two of them, but let's just write just the anion, okay? And then this one right here, I'll do it because it's easy. It's K plus and I minus. So far, so good on that, guys? So basically on the left side, you have a solution, right, that contains Pb2 plus and NO3 minus. And they're floating around because again, these guys are aqueous, they dissolve in water. Okay. And then you have this solution right here. That's K plus and I minus. Okay. So far, so good? Now, if you take a look at them both separately, the ions are dissolved in water and they're separated, right? But what happens is if you mix them together, okay, so if you mix them together, what's going to happen is first they're going to be dissociated, okay? But they're going to, these ions from the separate solution, they're going to start coming into contact with each other. Does that make sense? So here they're separated, but if you mix them together, let's just say they're in the solution now. They start off separated, but they're going to start coming into contact with each other. So Pb, when it was separated, it only was able to flirt with NO3 minus. Okay, and it didn't work too well. NO3 minus is like, nah, we're never going to get together. But Pb is now able to connect with another anion, right? He has access to a different ion. And he's going to start flirting with iodide. And iodide is like, oh, Pb is kind of cute. Let's get together and get married. So they're going to stick together and boom, they're going to combine and turn into PbI2. And this is a solid. So this will be your precipitate right here. Okay, so the point is once you mix them together, the ions are able to access different ions and they're able to form things that don't dissolve in water. Yeah.
What makes silver work to some of the elements?
That kind of goes beyond the scope of this class. So we'll talk about it after, just because I want to get through as much as I can today. Okay, we'll talk about it after. Does that make sense, guys? Okay, so Pb again, when it was just with nitrate didn't want nothing to do with Pb. But when Pb was able to hit up iodide, they were able to get together and become a precipitate. Yeah.
So Pb was able to have
not necessarily. It's because they mix together. Yeah.
Is Pb the precipitate because it's heavier?
Not necessarily, no. Yeah. Again, that's beyond the scope. We'll talk about that later. Yeah. For now, I'm going to give you some rules for how to figure out something that's precipitate. But does this make sense why a precipitate forms?
Yeah.
Yes. Okay. Just want to make sure about that. You guys are jumping way ahead of me still. Okay. So that's how precipitates form. Now let's talk about the solubility rules. So these are rules that you have to remember, and you only need to remember 2 for the AP test. Okay, and this you have to memorize. I know there's this table right here. That's very exhaustive, but you don't need to memorize all this. You just need to know these. Okay, so compounds with an alkali metal. So if you have an ionic compound with a metal, the cation is on the first column of the periodic table, okay? Or if the cation is ammonium, NH4 plus, it will, no matter what, dissolve in water, okay? It does not want to get with anything. It will never form a precipitate, okay? Okay, so if you have an ionic compound and the cation is from the first column of the periodic table, or it's NH4 plus, it will always dissolve in water. It will always be aqueous. Okay. Always. Yeah.
Does that apply to hydrogen?
No, hydrogen is not applied. Good question. Okay. The other one that you have to remember is that if the anion is nitrate, it will also always be aqueous. Okay, those are the two that you have to know for the AP test. There's a lot of exceptions for different rules and stuff like that, but the only ones you have to remember are these two rules, because there's the ones that have no exceptions. No matter what, compounds with a cation from the first column or ammonium will be soluble, and if the anion is nitrate, it will always be soluble. Okay. So again, you guys have to memorize that for the exam, not just for this class, but also for the AP tests. Okay. All right, so let's see if you guys understand that. So for these next problem for 4.2, make sure that you refer to this as well. You might need this table, but see if you guys can figure out if these compounds right here are soluble or insoluble. Soluble means dissolves in water, so it's aqueous. Insoluble means that it does not dissolve in water, so it's a precipitate, so it's a solid. Okay, figure out if these four compounds, which ones dissolve in water and which ones do not dissolve in water. Okay, so take about 2 minutes to do that. All right, so I think it's always easier if you guys just write the chemical formula. So I'll write them for you guys and you can tell me if they're aqueous or not. So we got sodium carbonate. Okay, is this guy going to be soluble or insoluble?
Soluble.
Yeah, this guy is soluble. Why is it soluble? Yeah, there's Na. Okay. All right. Let's go to the next one. The next one, you got the formula already. PbSO4. Is this going to be soluble or insoluble?
Soluble.
Yeah, this one's going to be insoluble. Now, this is not one of the rules you had to memorize, but I did tell you to look at this table up here. And it tells you that anything with sulfate is soluble except Pb, which is one of the exceptions. All right. So that one's going to be insoluble. And again, you don't need to memorize that for the test, but when you do your assignments and stuff, that might be helpful. Yes.
Will you be given one of these sheets on the test?
No. So that's why you only need to know the solubility rules you have to memorize.
so
This is just for your assignments.
So it's like if it doesn't apply the rules, then
Yeah, then you can just assume you don't need to worry about that. Yeah. All right, let's go to the next one. Cobalt hydroxide is COOH2. And is this guy soluble or insoluble?
insoluble.
Yeah, this is also insoluble, and it's because of the rules up there. Okay, and then the last one, you got barium nitrate, which is BaNO3/2. And is this soluble or insoluble? Soluble. Why? Yeah, because it has nitrate. Okay, so just make sure you remember those rules. If it has alkali metal, it is always soluble. If it has nitrate, it is always soluble. Okay. You guys want to hear a chemistry joke?
Yeah.
What do you do with a dead chemist?
Very.
You bury him. Ha 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 ha. All right, let's move on. Okay, so now we're gonna start looking at reactions between them. Just now we talked about, hey, is this compound soluble or insoluble? Now we're gonna talk about if we mix them together, are you gonna form a precipitate or not? So I'm gonna show you how to do the first problem, 4.3, and then I'll have you guys do the other ones on your own, okay? All right, so you got BaCl2, and you are reacting that with K2SO4, okay? Now, I'm just going to let you guys know right away, and I'll do this in blue. both of these are aqueous. Okay, so you don't need to go look up the rules. Okay, what we're gonna do now is we're gonna figure out whether mixing these two solutions will create a precipitate or not. And so to do that, we have to perform something called a double replacement reaction. And that's where you take the cation of one of them, and then it's like a date swap. You switch people that you are hanging out with. Okay. So BA is gonna kick out chlorine. It doesn't want to hang out with chlorine anymore, and it's gonna hang out with sulfate. Okay, so what is the charge on barium? 2+. And what's the charge on sulfate? 2-. So easy peasy. It's gonna produce BaSO4. You don't need to balance nothing. Okay. All right, I want you guys to take a look at the solubility rules above. Okay, is barium sulfate soluble or insoluble? It is insoluble, which means it forms a solid. Okay. So mixing these two compounds will form a precipitate. And this right here is going to be the precipitate. Okay. And if you wanted to finish the equation, obviously the other ionic compound would be KCl, but this one does not dissolve in water because of the potassium. Okay. Okay, and I know this isn't balanced, so please don't tell me it's not balanced. Okay. All we're looking for is a precipitate.
So it doesn't matter when it's not balanced.
Yeah, I mean the question is just asking for the precipitate, so yeah, you don't need to balance this one. All right, you guys think you could try one on your own? All right, see if you could try 4.4 and see if reacting these two solutions will form a precipitate or not. Okay, so for this one, I'm gonna show you guys how to solve it, I guess in a little different of a format. Barium nitrate is going to break apart into Ba2+ and NO3-. Okay, we've looked at these before. And KOH is gonna break up into K+ and OH-. Okay, and these are both soluble, right? Because this one has nitrate, this one has K. And so what we're gonna do is we're just gonna see if the combination of the other ones are going to be soluble or not, okay? So if you look at barium and hydroxide, is this gonna form a precipitate?
Yes.
Is it? So let's go up to the rules. So if you take a look at this, it says insoluble, OH. Okay, the exceptions are, yeah, so this one is going to be soluble. Because if you look here, the exception is being insoluble. It's the opposite. So OH is typically going to produce a precipitate, except when it reacts with these. So when it reacts with barium, it is not going to form a precipitate. Okay, so just be careful with reading that. If you react these two, you're going to form BaOH2, and this is going to be aqueous. Okay, so be careful when you're looking at that chart. Yeah. The chart, no, you're only gonna need to know the rules I told you to memorize. Yeah. Okay, let's take a look at the other one now. So KNO3, okay, this one should be easy. Is this soluble or insoluble?
Very much.
Very, very much soluble, because both K and NO3 can't stay with any other ions. Okay, you could think of these as Taylor Swift. Can't stay with anybody for very long.
You think those people work out? No.
Never. I just need her to break up so she can drop a fire album. I could blast another PR.
Yeah, she just dropped. She just dropped. Unfortunately, yeah. Very, very.
All right.
I'll take you.
We don't need to hear it. Alrighty, guys. I think you guys get the idea. We'll skip 4.5, so we'll close it right there. But I just want to make a quick announcement about homework dates. Just make sure you guys keep up with the homework calendar. With the dates. We do have another test coming up, I think, next week. At the end of next week, so just keep that in mind. All right.